So ladies and gentlemen, once again, you are most welcome to tabbytalks.com. So as I promised you last time, today we are going to be looking at the bit and bytes. To start with, one definition. A bit and a byte, these are units of measurement which are used to quantify digital data storage and transmission. So we are saying these are what? These are a bit and byte. These are units of measurement. These are units of measurement, and these units of measurement, they are used to quantify data storage and transmission. We have two main keywords here. Quantify digital data storage, meaning these are the unit of data storage or measurement on how data is stored, and then how it is transmitted inside the computer. So a bit is the basic unit of information in a computing and digital communication. That's what you need to know, that when I talk of a bit, in simple terms, it's a basic unit of information in computing and digital communication. It has a value of either 0 or 1. As you can see here, this is a bit. And when I say it has a value of 0 and 1, so you can say I have a 1 here, I have a 0, I have a 1, I have a 0. So this is what we call the representation of bits. So it has we're saying it has a value of either 0 or 1, and it is used to represent a binary code. We say the computer is computer language is computer understand the computer has the language which is in the binary form of zeros and one. So whenever we are trying to deal with this binary code, we have to know that underlying languages of computers are in zeros and one. So a byte, on the other hand, is made up of 8 bits. So you have to count 8 of them. Say 1, 2, 3, 4, 5, 6, 7, 8. When you count 8 of these bits, you come up with 1 byte. I repeat, 8 bits is equal to 1 byte. 8 bits is equal to 1. As you can see, 1 byte is equal to 8 bits. So a byte is used to store a single character. A single character, it can be a letter like A, B, C, but just a single character of A is what we call a 1 byte, such as a letter or a number, and it's the smallest unit of a computer memory that can be addressed in most computers' architecture. So normally when we are dealing with computer architecture and when we are structuring the memory of a computer, we base on the bits and this, how the capacity, how best a computer can store these values or these bits. So for example, we said 1 bit or 1 byte, which is 8 bits, is represented with 1 character. It can be a letter like A, it can be a letter like B, or it can be a number like 1 or 2 or 3. So together, bits and bytes allow us to store and transmit complex data. Of course, when the bits and bytes, when we put them together, of course, we are able to store data, and then we are also able to transmit complex data, that is huge data, such as text. I mean characters and numbers combined. Then I have images. Then these are photos. I can also have audios, those are the sound. Then we have videos. Video is, a combination of both images and sound. And then a series of binary digits. The amount of data, of course, can be stored in device is typically measured in kilobytes, megabytes, gigabytes, and terabytes. That's what you need to know. For example, in a high definition movie, it can take up several gigabytes of storage if you want to store it inside a computer. While in a simple text document, of course, this can just take small kilobytes. So that's it all, guys. As you see here, if we are to put in form of representation of on and off, you see like a 1 represent a true whereas a 0 represents the false. Like when you put the when you switch the bulb on, that one is the same as 1, and when you switch the bulb off, that is the same as 0. So a 0 is off, 1 is a true. And as we go to Canaf map and architecture diagram and calculations, we are going to see how this one is done. But generally, this is the representation in binary form. We said a bit is a measurement unit that can only have 2 values, a 0 and a 1, whereas a byte is a combination, or is a unit that indicates the amount of data consisting of 8 bytes. For example, you count 8 bits, that is 0, like 1, 2, 3, 4, 5, 6, 7, 8. I repeat, I say 1, 2, 3, 4, 5, 6, 7, 8. So eight of these bits, these bits, 8 of these bits, they give us what we call one byte. They give us what we call 1 byte. So 8 of these bits, they give us 1 byte. And then the other important thing before we end, we've said that bits and bytes are units of measurement, which are used to quantify digital data storage and transmission. And we have seen that different measurements. We said 1 byte is equal to 8 bits, and then what about 1 kilobyte? Of course, a kilo is 1,000. 1,000 bytes of them is equal to 1,024 bytes, and then 1 megabytes. That's mega is a million, so 1 megabyte is equal to 1,024 kilobytes, and then 1 gigabytes is the same as 1,024 megabytes, and 1 terabyte is the same as 1,024 gigabytes. So normally, when you are dealing with this, of course, what you have to put into consideration is that we are talking about memory and storage. Memory and storage, how computers store data and how they read data, how they interpret each and everything we enter into the computer. Of course, we say it is done into binary numbers, and the binary number, these are 1s and 0, and the 1 and the 0 is what we call a bit, and the combination of 8 of them is what we call a byte. So, and this bit and byte is the one that helps us to quantify and store data, and also be able to transmit data within the computer system. So thank you guys for following, and I know we have a lot to do. We still have more videos to come. At this time, I want to say thank you. Keep subscribing to our channel, and register with our website tabbytalks.com, so that we can share and have a variety of videos together. So let's meet up in the next video. Thank you very much.